1:18 in the afternoon. Daniel, a 36-year-old office worker, closes his laptop and looks at the clock. He has just finished a large lunch. Rice, bread, meat, and a sweet drink. 10 minutes earlier, he was answering emails quickly. Now the screen in front of him seems strangely difficult to focus on. His eyelids feel heavier. His movements slow down. The meeting scheduled for 1:30 suddenly feels much harder than it did this morning. Daniel has not been awake all night. He is not sick, and he has not suddenly lost motivation. His body has simply entered a different physiological state. The same thing happens to millions of people after large meals. But the reason is more complicated than the common idea that digestion simply steals blood from the brain. Post-meal sleepiness is sometimes called a food coma, but that phrase can make the phenomenon sound simpler than it really is. For an office worker like Daniel, several processes can overlap at the same time. The meal changes blood glucose. It changes insulin levels. Nutrients enter the bloodstream. Signals from the digestive system communicate with the brain. And the body's internal clock is already moving toward a natural period of lower alertness in the early afternoon. That last part is important. Daniel is not experiencing digestion in isolation. He is eating at a time when his circadian system may already be reducing wakefulness. Research on human sleep and circadian biology suggests that the afternoon contains a natural dip in alertness, even when someone has had a normal night's sleep. So the heavy meal may not create sleepiness from nothing. It can amplify a biological window in which sleepiness was already becoming easier to feel. The first part of a story begins in the digestive system. When Daniel eats a large meal, his stomach and intestines begin processing a substantial amount of nutrient. The gastrointestinal tract is not simply a passive tube. It contains an extensive network of neurons and communicates continuously with the brain through hormonal and neural signals. Researchers describe this communication as part of the gut-brain axis. One important pathway involves the vagus nerve, which carries information between the digestive system and the brain. Research summarized by Meyer and colleagues at UCLA in a 2014 review in Nature Reviews Neuroscience described the gut-brain axis as a complex communication network involving neural, hormonal, and immune signals. That means the brain is receiving information about what is happening in the digestive system while the meal is being processed. Then there is blood glucose. After a carbohydrate-rich meal, glucose enters the bloodstream and the pancreas responds by releasing insulin. Insulin helps tissues take up and use glucose while also influencing how nutrients are handled throughout the body. But the story is not simply more sugar equals more sleep. A 2016 review by researchers including Frank Hu and colleagues, published in the journal Obesity Reviews, described how meal composition, metabolic responses, and timing can influence post-meal physiology. Different meals can therefore produce different physiological responses. Another piece involves hormones and brain signaling. Eating changes several signals associated with appetite, digestion, and energy balance. Some of these signals interact with brain regions involved in arousal and sleep regulation. Research by St. Ange and colleagues, published in 2016 in Advances in Nutrition, reviewed evidence showing that food intake, meal composition, and timing can influence sleep and circadian processes. And then there is the brain's internal clock. The human circadian system is regulated by the suprachiasmatic nucleus, a small region of the hypothalamus that coordinates daily biological rhythms. Research from the National Institute of General Medical Sciences and decades of chronobiology research have established that alertness naturally changes across the day. For many people, the early afternoon contains a period when wakefulness decreases. This is one reason the same lunch can feel very different at 1:30 p.m. than at 8 a.m. Daniel's heavy meal is therefore interacting with two systems at once. His digestive system is processing a large nutrient load, and his circadian system is approaching a natural dip in alertness. The result can feel like sudden fatigue, even though his body is actually carrying out a highly organized physiological process. There's a common explanation that sounds logical. After a large meal, blood rushes toward the stomach and leaves the brain short of oxygen. That is not an accurate explanation of ordinary post-meal sleepiness. The body has sophisticated mechanisms for maintaining blood flow to vital organs. Normal digestion does not simply divert so much blood away from the brain that the brain becomes sleepy. Research on postprandial physiology instead points toward a combination of metabolic, hormonal, neural, and circadian processes. There is another misconception too. People often assume that feeling sleepy after lunch means the meal itself has directly caused a massive increase in the brain's need for sleep. But the timing matters. A 2019 review by Panda and colleagues in the journal Nature Reviews Neuroscience emphasize how strongly metabolism and circadian timing interact. In other words, the meal and the clock can work together. Daniel might have felt somewhat sleepy at 1:30 even without the large lunch. The meal can make that normal afternoon decline in alertness more noticeable. The research does not point to one universal cause of post-meal sleepiness. Instead, it points toward an interaction between meal size, meal composition, metabolic responses, digestive signaling, and the circadian clock. Research from St. Ange and colleagues in 2016 suggests that both what we eat and when we eat can influence metabolic and circadian physiology. Research by Frank Shi and colleagues at Brigham and Women's Hospital has also demonstrated that the timing of food intake can interact with the body's circadian system and metabolic regulation. Their 2009 study and proceedings of the National Academy of Sciences show that circadian misalignment can affect metabolic physiology. And laboratory research on human circadian rhythms has repeatedly demonstrated that alertness is not constant throughout the day. For an office worker, this creates a simple but important distinction. The sleepiness after lunch is not necessarily the body shutting down, because digestion is taking all its energy. It is better understood as several normal biological signals arriving at roughly the same time. A large meal increases digestive and metabolic activity. The brain receives signals about that meal, and the internal clock is already shaping alertness. Together, those processes can produce the familiar afternoon heaviness. His digestive system is working. His metabolism has shifted. His brain is receiving signals from the gut. And his circadian clock is passing through a period when alertness can naturally decline. The feeling may be uncomfortable, especially when the next meeting is already beginning. But the biology behind it is remarkably ordinary. Sometimes, the sleepiness that arrives after lunch is not a failure of willpower. It is the combined effect of what the body has just eaten and what the body clock was already preparing to do.